Let's talk about the square root. So you're given a non-negative integer x. So compute and return the square root of x. So since the return type is an integer, so the decimal digits are truncated. So the problem is if you use a linear search, you will get TOE. So if you actually need to find out the number for the square root, you need to truncate your number. So in this example, the square root of 8 is actually 2.8, but we get rid of decimal, so you have to return 2. So this question is actually um, a little bit difficult. So what happens if the number is what? So 11 square is actually 121. So what happens if the x is 120, right? So let's just think about it. So if the x is 120, so from 1 to 120, using a binary search, I find out the middle value, which is 60. So the value I need to keep searching is actually the left side, right? So the left side. So I need to get rid of my right side. So I need to move my right pointer to here, right? And I will just keep finding 30. So it's still going to be moving on my right pointer to the mid, right? So at some point, right, at some point 1 to 30, you'll find 15. So I still going what? I still going on my right side. But 1 to 15, 1 to 15, right? The middle value is 1 plus, well, which is 8, right? So how do you find the middle value? Is what k equal to 1 plus, I plus j minus I divided by 2. So this is how you find the middle value. And this is 15, right? And then, this should be on the right side. So I need to move my left pointer from here to k plus 1. Think about it, should be k plus 1. So at the end, we know we move our left pointer k plus 1. So at the end, we will have to At the end, we'll have to return the left pointer to I minus 1. This is because we always add 1 just in case, right? And this is pretty much a solution. So here's it. So in I equal to 1, j equal to x, while I less than j, I need to find out k equal to I plus j minus I divided by 2. And I need to find out the value equal to x divided by k. So if value is actually equal to k, if value is actually equal to k, we know we can return k. So what does this mean? Is actually what? K times k equal to x. So this is k times k equal to x. So using a different scenario, we can prove so this is k times k equal to x. So and using a different expression, we can prove this is what we find out 2 times 2 equal to 4, right? But what happens if value is less than k, right? What happens if value is greater than k, right? There are two different scenarios, right? So if value is less than k, you need to move your right pointer, which is j equal to k, and this is going to I equal to k plus 1. And at the end, I would just have to return I minus 1, right? This is because we're always adding 1 just in case, right? And then we're still including our j pointer in the range. So we will just keep checking until I is not valid. So this is pretty much a solution. Alright, so I passed the test case, but the problem is the problem is the base case. What happens if the x is less than 2, right? Basically just return x, right? And this is still going to pass the test. So let's talk about the time and space. So in this scenario, the time is going to be log n. It's cut half every single time, so it's log base 2, right? So the space is what? Constant. So this is a solution, and I will see you next time. Bye.